You, helpful guide to successfully navigating awkward moments with a heinous shrub.
It's not actually. Phil was just trying to be funny. I am Kara Smith. I'm a senior at Calvin College.
And I'm Phil Tubergen. I'm going to be a junior at Calvin College.
And we're actually studying the influence of autumn olive on soil community chemistry and plant community composition.
And so just a little background on what an invasive species is, because autumn olive in America is labeled as an invasive species. They are often introduced as food in a community, or they are introduced unintentionally. So the European black rat was brought over on ships, and sorry, I thought Michelle was telling me to speak up. But and they're an issue in plant communities where they are not native because they typically outcompete native species through various methods, whether it's allelopathy, which is releasing of chemical warfare on other plants. So basically, different parts of the plant will release certain chemicals that can kill off other plants or other parts of plants. And this outcompetitiveness can dramatically reduce biodiversity in a given area. And because of that, the government has invested over $120 billion a year in the control of invasive species.
So, just a little bit about autumn olive in particular. As an invasive plant, it's really good at competing. One of the ways that it competes better is that it has higher photosynthetic rates than most other plants. So, past studies done, actually, they've been done here, they can show that in the forest understories, autumn olive is just plain growing faster, it's getting more light, more water, and so it's able to really outcompete and take over an area. It's also nitrogen fixing, so it's able to go into a lot of areas that normally other plants can't. So in nutrient deficient soils, it can get its own nitrogen and grow really well. It was actually introduced in southern Illinois and other areas in old mining areas that were very nutrient deficient. So that's how it first came. It was because it's nitrogen fixing. And it's able to do this through a symbiotic mutualism with the bacteria Frankia. And there's actually something weird going on there too, because it only works with this Frankia bacteria, but autumn olive can go into places that it's never been before and do really well, and somehow the Frankia follows it, and it's just something weird is going on, because a lot of times autumn olive, since it has berries, it disperses through birds. So it'll go through the bird system and still have this bacteria somehow. And then there have also been spring and fall soil testing done on autumn olive, and something weird is going on with the nitrogen there too. In the fall, there's a lot of nitrogen present, but then in the spring, when they do soil testing, they don't find any. And this is in the spring when the soil is still frozen. So something really odd. It's not really what you typically see with plants during those seasons. Then there's also a potting study that was done on autumn olive where native plants were put in with the autumn olive, and they'll do better in the first year than they would by themselves because that nitrogen is there to boost their growth. But then over the winter, the plants that are with autumn olive, only 40% of them move back. So it looks like there might be some allelopathic interference by the autumn olive. So that's kind of what we're looking at now.
And so our total hypothesis is that autumn olive outcompetes neighboring plants by changing the soil chemistry within its rhizosphere through an increase in the amount of plant-available nitrogen and a reduction in plant-available calcium, phosphorus, and other essential ions. It is also allelopathic. All of this will result in a changed plant community. So kind of what this means is that autumn olive changes the chemistry within its rhizosphere. Its rhizosphere is the area that its roots and the overhang area that its branches take up, but mostly focusing on the roots. And so in the past studies, we've seen that it changes soil chemistry, but we really want to nail down how it changes the soil chemistry and whether or not it's allelopathic. And we'll be assessing it through various means.
Like the soil testing. So with the soil testing, we'll go out and we'll take the soil cores, and we have sites with autumn olive, and then we have a comparative site without. So we'll take soil samples from each, and then we back it up, and we'll put it into our pots, stick it in a convection oven, so we'll burn off all the water, and then we'll also put a soil sample into the muffle oven, which will burn off all the organic carbon. So we're trying to see kind of what the organic carbon content of the soil underneath the plants is comparative to not, and then we'll also take some solutions. We'll do both a nitric acid and a water solution so that we can kind of see what ions are there, and we run it through a chromatography machine. So to give you an idea of the size of the study, at the moment we're looking at the difference between the autumn olive plants in the forest and the autumn olive plants on the meadow. So at each of those two sites, we'll have 10 different plots with autumn olive and 10 different plots without. So we'll take 40 soil samples from all of those, and then we're going to send 3 samples in per plot. So we're sending in about 120 of these samples through the ion chromatograph. So we'll get a lot of data from that to see exactly what's going on with all the different ions in the soil underneath autumn olive.
The next thing we will be assessing is biodiversity. In order to do this, we're going to be using a 1 meter squared quadrat, which is basically just a frame that has an area of 1 meter squared. And we're going to throw that out into our different plots, both with autumn olive and without autumn olive. And within that quadrat, we're going to assess the number of species and the number of within each species of plants there. And we're going to use various indexes. The Shannon-Weiner index and the Simpson index are both similarity indexes, which will show us basically the biodiversity level within each of the plots. And then we're looking at the Bray-Curtis dissimilarity index, which will show us the difference between plots with autumn olive and plots without autumn olive.
Then to look at allelopathy, we've been making autumn olive teas. So we have these teas laying around in the lab that people find. It's kind of fun because they smell like apple juice. But we go out into the field and we'll take leaves from autumn olive plants. At this point, we're not exactly sure. We're taking leaves both from the meadow plants and from the forest plants in case there's a difference in how they react with their environment. So we'll make 2 different teas. We take leaves from the plants and then we cut them up into little bits and we put them in a beaker with water, and we let them sit overnight, actually for 48 hours, right? Mm-hmm. So we let all the ions and we let it diffuse into the water. Then we take all these little seeds. We have 4 different species at the moment: white clover, radish, fescue, and we might be getting another one soon. We put them into the Petri dishes with some paper. We set them up. Then we put our different, so they look like this. Those are white clover. They're very, very tiny. Then we put the solution into each of these Petri dishes. So we have a meadow tea and the forest tea, and we'll also have the water. So that's a control. We have the water to see if the autumn olive is actually doing anything. So we're looking to see if the growth is inhibited by these different teas. So we'll count the germination at about 7 days. Although at this point, it's looking like we might have to count it sooner with the white clover. We're just 2 days in, and a lot of them are already sprouting, so we'll see. But we're going to do comparative tests and sets to see if the autumn olive tea is really actually inhibiting growth of these seedlings.
And the last thing we will be assessing is the protein, chlorophyll, and photosynthetic rates of certain plant species that we find common in the biodiversity indexes within autumn olive plots and non-autumn olive plots. And so to assess chlorophyll content, we're using a Minolta chlorophyll meter, and basically what it is a little spectrophotometer that you clamp onto the leaf, and it will assess a certain amount, or a certain nanometer wavelength of light, which happens to be the wavelength of chlorophyll, and it'll give us a readback back saying about how much chlorophyll is in each plant. And this will help us look at whether or not autumn olive has increasing chlorophyll throughout the summer, and whether there's decreasing chlorophyll in the plants around autumn olive. And then we will also be assessing the protein, leaf protein of certain plants, and we're going to be doing that with a Bradford's colorimetric assay, which basically we just grind up a bunch of leaves, put them in Bradford's reagent, and then assess the color. signify the health of the plant. And then we're also going to be looking at photosynthetic rates. If we get our meter working, it's currently not functioning. Basically, the fan is not working, so gas can't be blown through the meter, which is a significant part of photosynthesis because it gives off oxygen and takes in carbon dioxide. And so it measures the different rates at which those are digested, and the fan isn't working, so we can't really do much with it, which is unfortunate. But once it gets working, we'll see if we can get that. Are there any questions?
That was a slight whirlwind,
sorry.
but yeah. Any questions about that?
Is this the autumn olive that has the sweet smell when the flower comes on?
Yeah.
And the very red berries that people like to make
Yeah,
jams
you
and
see them
things
all,
with.
but they seem to grow like a bush,
Mhm.
and there's different species of them. Is that what you're saying?
Yeah, well, we've just noticed that between the forest and the meadow, the leaves have kind of a different habit to them. So one of our side projects is we might do some genetic testing to see if there actually is a drift going on there. We're not sure. We're just trying to keep them separate in case there is a difference.
I
'Cause the
mean,
plants-
if it's costing the government $120 billion,
just invasives
why don't we
in general.
just chop them down? Because they're going to get all these other benefits?
Well, the issue with that is that chopping it down itself doesn't necessarily control the problem.
Right.
And so it takes an application of herbicide and a lot of manual labor to actually kill these plants. And once they hit about 3 years of age, which is typically what you see in forests and fields, they start releasing the berries like crazy, and so it just spreads really, really fast.
Yeah.
So,
And then one of the things we're trying to see is if it's influencing the chemistry of the soil. Because if that's influenced, then we need to do something else as well once we take the bush out. Because plants will still have a hard time growing there after that. And it wasn't 120 billion just on autumn olive. That's invasive plants in general.
Okay, thank you.
I'm just curious, how you decided in the allelopathic study, how did you decide to go with leaf extracts rather than, for example, looking at roots?
We are doing roots too. I'm sorry. It's just we've been doing leaves at the moment, and so our next step is to do roots.
Okay.
So yeah, sorry, I forgot to mention that. Thank you. And then after, we're going to see if anything is seen in the roots and the leaves. If we do see any indications, we're probably going to go to soil sampling then and see how it affects the germination.
How does that preliminary data look with your leaf extract? Have you got anything yet that looks?
No, we're about 2 days in and we're just kind of eyeballing, but it did look like there was some inhibition going on until just when we checked it right before we came. So we really can't tell yet.
Yeah.
Well, I will say there will be an opportunity to speak more with the researchers afterwards. We have a very short window of about 3 minutes after each talk to questions. So anyways, thank you guys.